Hello students, in today's session we will talk about chi-square applications as non-parametric test. There are two possibilities for the application that depends upon the number of variables we deal with. If we are dealing with one qualitative or categorical variable, then the desired application is goodness of fit test. If we are dealing with two qualitative or categorical variables, then the application would be test of independence, because in case of a two variable scenario, we would like to see if there is a dependence of these two qualitative variables or attributes. Now let's start with the exercise that I have selected for goodness of fit test. So that's question number 12.14 from the book. According to the Census Bureau, according to the current housing reports published by the Census Bureau, the primary heating fuel distribution of all occupied housing units is as follows. Over here, variety of means according and their relative percentages we are providing this data in the entire US. And according to this table, 56.7% of the households in the entire US, according to this data, are using natural gas. 14.3% fuel oil kerosene, 16% are using electricity, 4.5% LPG, 6.7% wood, and 1.8% other. So there are six different means of primary heating fuel that we are given in this data. The later part of the question says a random sample of 250 occupied housing units built after 1974 is the following frequency distribution. So the data are collected from the households that were built after 1974, and the distribution in the randomly selected 250 households, 91 out of 250 are using natural gas, 16 out of 250 are found using fuel oil or kerosene, and so on. Now, what hypothesis we are asked to test, we need to read the question carefully for that. Do the data provide sufficient evidence to conclude that primary heating fuel distribution of occupied housing units built after 1974 differs from that of all occupied housing units? So we need to write up the null and alternative hypothesis accordingly, and we write this down as primary heating fuel distribution, PHFD stands for, in the households built after 1974 differs from that of. Here we need to write down the statement that we are asked to test in H1, we all know. So over here we need to state the contradiction to that, and instead of writing down differs, we need to write down here does not differ. So does not differ from that of all occupying housing units. Over here you can see that we have given room to the qualitative statement in the hypothesis testing procedure. An alternative hypothesis we write down as the statement given in the question as primary heating fuel distribution in the households built after 1974 differs from that of all occupied housing units. Now, as usual, as the second step of hypothesis testing procedure, we need to state or mention the level of significance. That's 5% we are given in the question. And the test statistic for this application has a different structure of chi-square, and that is the observed frequencies take away expected frequencies, and that difference should be raised to square divided by Fe, and this summation sign is applied on the entire fraction, we can notice. And then we need to go for the critical region. This is always right tail test, and I would be discussing the reason for that in a short while. First, we will go for DF. DF are the number of categories that are six in terms of prime reheating fuel means. So 6 take away 1 would give you 5 degrees of freedom. So chi-square no point no 0.05 with 5 degrees of freedom would give us a value. Let's check from chi-square table. No point no 0.05 column we can find on the second page of chi-square table. That's 5 degrees of freedom, and 11.04070 is the value. 11.070 is the value. This we can classify as the rejection region for H naught, and this part as the non-rejection region for H naught. And accordingly, we write down the statement as the condition under which H naught would be rejected, as H naught would be rejected if calculated value of chi-square exceeds 11.070. Now we need to copy the data in the computation section. The means of PHFD we denote as X. That's these are the F naught values that we will write down in the first place. Primary heating fuel, natural gas 91, fuel oil and kerosene 16. natural gas 91, fuel oil 16. Then we have electricity 110, LPG 14, electricity, LPG. Then we have the other two categories as wood and other. Wood 17 and other 2. So these are F naught values. That is making 250 housing units in total. Now, FE values we can compute when we multiply this as the number of households or uppercase of n times the percentages that we are given in the very first table. And these percentages we can consider as probabilities. So 0.567 times 250 gives us 141.75 that can be rounded off to 142. Then for the second value, 14.3% we are given for kerosene oil and fuel oil. So 14.3%, 0.143 times 250 gives us 35.75 that can be rounded off to 36. In the same way, 16% that can be expressed as 0.16 multiplied by 250, that's 40, gives us the percentage or the number of households that are using electricity as or in terms of the expected frequency. Now 4.5%, 0.045 times 250 is giving us 11.25 that we can round off to 11. The next value is 6.7%. So 6.7% can be expressed as 0.067 times 250 gives us 16.75. That's it. Can be rounded up to 17. And then the last one, that's 1.8%. So 0.018 multiplied by 250 gives us 4.5, and that we can round off to 4. And just check the total again. That should be making the sum of 250. 142 plus 36 plus 40 plus 11 plus 17 and plus 4. That makes or gives us 250 exactly. Now we apply this formula. That's the formula of chi-square. What it tells us, I am writing it down or copying down again. That's the difference or square difference between F naught and Fe. We have taken in the numerator and divide that by corresponding Fe value, and then we need to take the sum of entire column. So F naught minus Fe whole squared divided by Fe. So we need to take the difference of the two values. 91 take away 142. Then raise this to square and then divide this by 142. So the very first value is 18.32, rounded off to two decimal places. Then similarly, 16 take away 36 gives us 20. 20 squared is 400, and 400 should be divided by 36. That's 11.11. Then we have 110. Take away 40, then square, and then divide by 40. That's 122.5. Then 14 take away 11 squared divided by 11 is 0.82, rounded off to two decimal places. Then 17 take away 17 divided by 17 gives us 0. 2 take away 4 is 2 minus 2. Squared is 4, and 4 divided by 4 is 1. Now adding them all and comparing it with the tabulated value, that's 11.070 we got from the chi-square table. The sum is 153.75, and we can see that chi-square calculated, that's equal to 1.153.75, is clearly or significantly greater than the value that we obtained from chi-square table corresponding to the given significance level and 5 degrees of freedom. It is clearly or significantly greater than 11.070. Therefore, H naught is rejected, and it can be concluded that primary heating fuel distribution differs significantly from the household in the household built after 1974 as compared to all occupied housing units in the entire US. So, decision is since calculated value of chi-square falls in the rejection region, therefore H naught is rejected. And conclusion we write down as the test results are statistically significant at the 0.05 significance level, and data provide sufficient evidence to conclude that primary heating fuel distribution in the housing units built after 1974 differs from that of all occupied housing units. So, focusing on now one more question from the same topic. I'm using 12.16, selecting 12.16 question. A wheel contains 18 red numbers, 18 black numbers, and 2 green numbers. The table below shows the frequency with which the ball landed on each color in 200 trials. At the 5% significance level, do the data suggest that the wheel is out of balance? So we will now state for question number 12.16, our H naught in H1, the testing statement is the wheel is out of balance. This is what we are asked to test. We will state the statement as a contradiction to the one we have stated in H1. The wheel is not out of balance. Now level of significance is alpha equals 0.05. Test statistic is chi-square. This summation sign is applied on the entire fraction f naught minus fe squared in the numerator divided by corresponding fe value in the denominator. Calculates the chi-square value for each category. Now, why this is always a right tail test is significantly important to understand. If we look at the structure of chi-square formula, and if we get f naught values closer to the fe values, then raising to square and divide this by fe will end up with a low value of chi-square. And lower values of chi-square falls in the left tail area under the curve. I'm going to draw the curve so that you can understand this in a better way. That's 0.05. Now, why we are defining rejection region on the right tail? For this, we have to look at the statement mentioned in H naught. The statement mentioned in H naught is the wheel is not out of balance. So it does indicate or reflect that the expected values, observed values, we are getting closer to the expected values. That is why we are saying that wheel is not out of balance. So F naught closer to Fe values will end up with a low value of chi-square, and that would be located closer to zero value. And in that case, we can say that closer to zero region is strongly supporting the argument that we have stated in H naught. Whereas the wheel is out of balance, we can conclude in this way or in favor of this statement only when we observe there is a greater difference between the f naught value and fe values. So if observed frequencies are greatly different from expected frequency, this is the scenario where we can say that wheel is out of balance because we are not getting the results as our expectations are greatly different from our expectations. Consequently, greater differences between f naught and fe values will end up or will give us the higher value or greater values of chi-square that must be falling on the right tail part. And we always define our rejection region on the basis of the region or the zone where H1 will be supported. So right tail is the part under the curve where H1 argument will be supported strongly. That's why it is always a right tail test. Now, how do we work out the degrees of freedom? There are three different colors or variety of colors we are given. So 3 take away 1 gives us 2. So chi-square 0.05 with 2 degrees of freedom would give us 5.991, I believe, as the chi-square value. Let's check from the table. So 0.05 is the column and 2 degrees of freedom gives us 5.991 as the critical value of chi-square for this hypothesis testing. Now what we do, we will state this in the form of statement as usual. H naught would be rejected if chi-square calculated exceeds 5.991. Now, we go for computation in the next step. Here we define our variable x as the colors red, black, and green, and the observed frequencies what we are given in the data are 88, 102, and 10. 88, 102, and 10. That makes 200 as a total. Now, FE we can compute on the basis of the number of times we have repeated that experiment is 200, or the number of tries are 200, times the probability with which the ball landed on each color. Over here, to estimate or compute the probability, we need to consider how many sectors are there in the entire wheel that follows a circular shape. So 18 are red, 18 are black, and 2 are green is giving us 38 in total. So the probability that the ball will land on red color is 18 out of 38 multiplied by 200. 18 out of 38 would be the same probability because the number of sectors are 18 for black as well. And then 2 are green. So that's 2 out of 38 times 100, 200. This is how we can get the three values computed for expected frequencies. At 94.73, we can round it off to 95. The second one as well, and that's 2 out of 38 times 200 gives us 10.52. So we can round it off or leave it as 10 because we have already rounded off the other two values to the next number 95, and if we round this last value to 11, that will affect the total and we need to have the total of 200. So 95 plus 95 plus 10 gives us 200. Now we will work out in the same way. So 88 take away 95 is 7. Difference is 7. 7 squared is 49. So 49 out of 95. And similarly, 102 take away 95 again gives us 7. So same 49 out of 20, 95. And then 10 minus 10 is 0 divided by 10 is also 0. So that's 0. That's 49 out of 95 is 0.52 if rounded up to two decimal places. Here as well, no 0.52. So no 0.52 times 2 or add the two together, two values. So that is giving us 1.04 as a computed value of chi-square. Here, the computed value of chi-square, which is 1.04, is clearly less than 5.991. That is the value we obtained from the table of chi-square. So the decision is, since chi-square calculated value, since chi-square computed or calculated value does not fall in the rejection region, therefore H naught is not rejected. And the conclusion for this problem is the test results are not statistically significant at the 0.05 significance level, and data do not provide sufficient evidence to conclude that the wheel is out of balance.